Okay, good afternoon, everyone. How did the homework go so far? Any questions about the homework before I start commenting on the quiz? Anyone? Okay. Can you go over 17? Sure. So for those who have questions, please put them on the chat. I'm gonna make one comment about the quiz and then I will proceed. So on the quiz, you had the following problem. So all of you have the problem. You have a function that assigns to each time t the amount of nicotine in a person's bloodstream t hours since the person finished smoking a cigarette. So I don't know why this is crooked today. I'm trying to fix it. Sorry. Yeah. Okay. And the graph of f is given below. Find the average rate of change for f for t between 0 and 4 and give unit with your answer. So that was the question. So I have a function that does the following. So every time t, that's what it does. It takes this for input and the output was the amount of nicotine at time t. So that was the output. And this is the graph. What does it mean? It means on the horizontal axis, always we have the input value. Means that's the time. And on the vertical axis, this is the output value, which is in this is the output value. It means the amount of nicotine. And the question was, we need to find the average rate for t between 0 and 4. Okay? That's what we have to do. Now we follow the formula verbatim, and then we try to picture it out. What does the formula tells me? The formula tells me that the average rate is the value of the function. So I want it for t between 0 and 4. It means the average rate at 4 minus the value at 0 divided by 4 minus 0. So that's verbatim what it is. So now we just have to read the graph and see what are the values. So what is f of 4? So we go back to my graph. That's the 4. And this is f of 4. So f of 4 is 20. So this is f of 4. What's f of 0? F of 0 is up here. So f of 0 is equal to 50. And what is f of 4 minus f of 0? So basically the question is between the minute you finish smoking the cigarette till 4 minutes later, the t is an hour. After 4 hours, of course, the amount of nicotine went down in your body. So you had 50 milligrams, and then after 4 hours, it went down that much. So that's the change in output, which is negative because the largest value is the negative value. And the change in input is to 4 hours. So that's the change. So the average rate of change is going to be, now we replace verbatim. F of 4 is my 50. Sorry. F of 4 is 20. Minus f of 0 is 50 divided by 4. And this would give me minus 30 over 4 or minus 7.5. Another question, what is the unit? The unit is, what this tells me that over a 4 hours period, we lost 30 milligrams of the nicotine. When divided by 4, it's giving me on average, how much we lost per hour. So this is minus 7.5 milligram per hour. So this tells me not exactly how much, tells me on average, the first 4 hours, we lost 7 milligram per hour. That's the unit. So that's the average rate. It's like a distance. On average, what's really going on. Now, That was the problem. Now a question is, of course, it doesn't mean every hour we lost 7.5. At the beginning, so after 1 hour, that's how much we lost. So after another hour, that's how much we lost. So we were losing less and less as times go by. So it's not the same rate. The graph is not a line, but on average, we have 7.5 milligrams. Okay, that's the way you should have handled this problem that gave some of you difficulty. All right, now I go back to your questions and we'll go now over number 17 and definitely number 2, letter H, whatever it is. So let me go first over number 17. Actually, let me have a look at number 7 because on Moodle you have a lot of problem like number 7. I want to make sure all of you can do it. And the question, I will do one of them, is you have a table. This is input and these are the output. And the table tells you that f is linear. It means that when you graph the function, you get a straight line. And they give us some values. So they tell me that at -2, the function takes the value 10. At 1, it takes the value 1. And at 5, it takes the value k. And the question is, you have to find k. It means basically, we have to find the output when the input is 5. So that's really k, it is. So to do that, we need to find a formula for f. Now, what do we know about f? We know a lot. We know that at -2, it takes the value 10. At 1, it takes the value 1. And it's linear, meaning when you graph it, you get a line. And the question is, at 5, if f is 5, what's the output here? Okay, so the best way to do this problem, the easiest way, is actually find a formula for f and then find the output. That's a line. So finding a formula, it means basically we're finding the equation of the line. So we do what we always do. We find the slope, which is the change of y minus 10, that's an average rate, over 1, minus, be careful, -2. A lot of you are forgetting about that. Which the numerator will give me -9. 1 plus 2, it's a 3, which is -3. That's the slope. And then we find the equation. You can use either form. So I will use the slope form. It means y. And I will use this point. This point is very easy to look at. So I will say the point 1, 1 on the line. It means y minus 1 equal -3 times x minus 1. It means y minus 1 is -3x plus 3. Now I solve for my y, giving me y equal -3x. I add 1 both sides, -3x plus 4. So it means that in function notation, it means my function. For every x, my function is given by -3x plus 4. So no matter what x is, that's my output. Now they want k. Now k is nothing more than f of 5. So I just have to plug it in. So it's gonna give me -15 plus 4, which is going to be equal to -11. Okay, so that's how to handle those problems. You have a table. They want the output at 5. You basically just verbatim find the formula, then plug in 5 into the problem. All right, questions before we go? All right, now we look at number 17 and okay, and we see what happens. So what is number 17? Okay. Number 17 is the following. Find the equation of a line. It goes through, so the line go through the point 10 minus 6. It go through that. I'll get back to you, Zach, give me a second. And it's parallel to the line given by the following equation. So that's my line. I'm going to call it L1. It goes through this point, and it's parallel to the line 5y equal minus x plus 15. And the question, we need to find the equation of the line. Sorry, I'm going to back up for 1 minute to answer Zach's question and then come back. Did you follow me up to the slope, Zach? Did you get the slope? I want an answer on chat quickly. Zach? Yes. And then I used the point slope. So I took a point. If x is 1, y is 1. I used, sorry, this one was right. If x is 1, whatever, forget about that. X is 1, the y is 1. So I used the point slope. Y minus 1 equal the slope, x minus 1. And then I solve. That's give me y minus 1 equal minus 3x minus plus 3. I added 1 to both sides, will give me minus 3x plus 4. Now I have the formula, I plug in 5 for it. Make sense? Okay. All right, so that's what it is. Now we have to go back, so I need a line that goes through this point and parallel. I need to find the equation. To find the equation, I need a point. They gave me the point, and I need the slope. So what's the slope of L1? Since it's parallel to this line, it means it has the same slope of this line. So let me call this L2 to be the line 5y equal minus x plus 15. Now, what's the slope of L2? To find the slope, you have to rewrite it under this form. We have to rewrite under this form. So now we need the slope of L2 to rewrite, and that's crucial, otherwise you cannot pick up the slope, to rewrite under this format. Once I rewrite it under this form, the coefficient of x, or what comes next to x, what x is multiplied by, is the slope. So now, what's going to be the slope here? What's the slope of the line L2? Equal to, because L1 and L2 are parallel, they have the same slope. So I know this one, I know the other one. It's equal to, what? That's my question mark. So I have to rewrite it. How can I rewrite it in this format? I have to divide by 5 both sides. So I'm going to have y equal minus x over 5. Everything has to be divided by 5. Plus 15 over 5. I need to know what is x multiplied by. That's what the slope is. So it's still not quite there. How I'm going to write minus this? I'm going to write it as minus 1 over 5 times x. So I know exactly what m is, plus 15 over 5 is 3. Now I know what my slope is. I know what x is being multiplied, but that's really what my slope. So my slope now is minus 1 over 5. Okay, and that's really crucial. You have to rewrite it this way. Now, what do I know about the line I'm interested in? So now I know 2 things about my line. I know the slope is minus 1 over 5 because the one I'm interested in is parallel to L2, and I know the slope of L2. I know a point. The point is given to us by the problem, then minus 6. So now I need to find the equation of the line. I know the slope, I know the point. I can use point slope form or slope intercept. So this one, I'm going to do point slope. So let's see what tells me. Y minus equal this. Here is the slope, minus 1 over 5. And here the point. The points are minus 6 for y and 10 for x. Now I have to rewrite it in a good format. So this will give me y plus, you have to be very careful with your minus, equal. I need to distribute minus 1 over 5x minus minus plus 10 over 5 will give me the 2. And with that, now finally we solve for y. I have to subtract minus 6 both sides, and this would give me minus 4. Okay. Please, any question? It's crucial that you guys can do that with ease because I have one more question, but for my own peace of mind, are you guys done? Can I move on? Okay, I will do the question that's being asked, which is, okay, let me do that first, and then I will do number 20, and hopefully we can finalize linear today. So one of your classmates is asking me about number 2, letter H. So I will take number 2, and I will do letter H. All right, it's a little bit tricky, but we have to do it. So here we have y equal 3x minus 4 plus x square root of 2. So it's a little bit tricky. And the question is, basically, they want me to find the slope and the vertical intercept. It means they want me to find both those. All right, to be able to find both those, I have to take this and rewrite it like mx plus b. Once I rewrite it like this, I know my slope, which is what's x multiplied by, and I know basically my intercept. All right? So what am I supposed to do? I have x here, and I have x here. So what do you want me to do? Suppose I ask you a slightly different questions. So suppose I tell you y is equal 3x minus 4 plus 5x. And I ask you to find the slope. In this simpler version, what would you do? I want you guys to start answering me on chat. What would you do? It's minus 3x. So what did we do? We took the 3x plus 5, combined, exactly. By combining them, it's not minus. 3 plus, it's 8x minus 4. It means the slope is 8, the intercept is minus 4. The intercept is what happened when x equal to 0. All right, so this is the same thing here, but we have the square root of 2, which is a little bit harder to combine by looking at it. So, but we can do it. How do you think I'm gonna combine here? So I wanna rewrite it basically in this format. That's really what I want. Okay, how shall I combine the terms? 3x plus x root 2. How did you get 8? I'll take you back. Here we are. 3x plus 5x. Amanda? 3x plus 5x. Okay, 3 orange plus 5 orange, that's 8x. So that's where the 8 coming from, minus the 4, which is the 4 which is coming from here. I just combined like term. Okay. Now here, how can I do, what can I do on this? How can I really combine those two? A little bit, you know, not much harder, but a little bit harder. So I need to combine this term and this term. What should I have? Anybody? Either put it on the chat or just in mute and tell me how do you think I should really combine those? All right. X and X, basically we can think of it as exactly as a common factor. So what you will have left inside? We're gonna have a 3, I'll put it in red, 3 plus the square root of 2. So I basically combined them, but because I have square root of 2, that combining them bit was a little bit harder. So it's basically 3 plus x plus the square root of 2 times x. Now let us, that's 3x plus x times square root of 2. Okay, and then the b is just minus 4. So that's really minus 4. So now what is the slope? The slope is what x is multiplied by. That's the slope. And vertical intercept is what happened when x is 0. When x is 0, the vertical intercept is minus 4. Or actually, it's better to write it as 0 minus 4. Okay. And graphically, this is a line. I will not, when x is 0, I am at minus 4. And this line, basically the slope is positive, is going to rise like that. Okay, that's the idea. That's a good question. So now I look at number 20 and then we proceed. Number 20, because usually some students ask me questions about Moodle and I want to make sure I share it with the rest. So number 20. Okay. And this is the problem here. Find the equation of a line that has the following property. The point, it goes through the point 10 minus 72, and it's perpendicular to the following line. 3y plus minus 3 over 7x plus 15 equal to 0. So we want a line which is go through this point and it is perpendicular to that. So to find the equation of the line, as usual, we need two things. We need the point and we need the slope. Now they didn't really give us, yes, it's 3 plus the square root of 2, exactly, that's the slope. Where am I? Yeah, that's the slope. What x is multiplied by, absolutely so. All right, so now to be able to do that, I need to find the slope of L1. Now, I'm gonna call L2 to be this one. And we saw last time, or at least I stated last time, what is the relationship between the slope? So if I call the slope M2, and I call the slope here M1, so we know that the slope of my line is minus 1 over M2. So now the question that if I know the slope of the line, L2, I can figure out the slope of M1. All right, that's really the idea. Again, this is not given in the proper format. It has to be written in the format mx plus b to figure out the slope. That's the only way I can do that. So there is a little bit of algebra involved. So let's see what the algebra is. So I have 3y. So I need to solve for y. Plus minus 3 over 7x plus 15 equal to 0. I need to solve for y. I need to solve for y. So 3y equal. So first I isolate the 3y. And this has to be brought from the other to the other side. It means I have to add 37x. And the minus plus 15 has to go to the other side. It means I had to take away minus 15. Still, this is not enough. I need to isolate my y. I need to isolate my y. So to isolate my y, I need to divide across by 3. Okay. So divide across by 3, I will get y equal. So every term is going to divide it by 3. every one of them. Every one of them. And now a little bit of an algebra here. Okay, this is a mess, of course. Let us do the algebra here very slowly. 3 over 7x, or you can write it, divided by 3. It's gonna give me what? We use the 3, it means 3 over 1. The property of fraction tells me that's 3 over 7x times a third. So multiplication of fraction, it means I will have 3x over 21. But obviously, this 3 and 3 basically can simplify. So I mean, I don't really have to write it like this immediately. I will have 1 over 7 times x. So we need some algebra, and this will give me 1 over 7 times x minus 15 over 3, which is 5. So algebra is in order. So now I have my slope. So the slope is 1 over 7. And that's the slope of the line, not the line I'm interested in, it's the line that's perpendicular to it. So finally, what is M1? So the slope of the line I'm interested in is equal to minus 1 over M2. So it's not minus M2, it's minus 1 over it. It means minus 1 over. M2 is 1 over 7. Back to fraction. It means minus 1 times 7 over 1, which is minus 7. Now I have my slope. Now the point. The point was given to me. The rest is algebra.
Really, Kat?
Oh. Thank you very much, Zach. My apology. Yeah, sorry. Okay. And the point is given to me, it's minus 10, 72. And now it's just using the formula itself. So I will have y minus equal. This is where the slope go, minus 7. The point is, this is minus 72, and this is minus 10. And now I just finished my algebra. Y plus 72 is minus 7x minus plus 7 times 10 will give me a 70. And I finally solve for my y, giving me minus 7x. And I subtract 72 from both sides, which will give me minus 2. Okay. So that's really the idea. So two main things: to find the slope, you have to rewrite it this format. In this case, you have to divide across by 3. This will involve some algebra, which is okay, we should be able to do. Now, being perpendicular, it means it's minus 1 over M2. Is minus 1 over 1 over 7, which will give me minus 7. And then I have a point, I have a slope, I have an equation. All right? Any questions? Okay. So now we're almost at the end of this section. So let me, we know how to find the equation of a line, so we know how to find the equation of a linear function. So let us see linear function. We're gonna work with them a little bit today with some story problems, simple ones. So linear function, basically they are functions. So function, it means you have a rule that you give it an input and it gives you an output. That's really what it is. Linear, it means that a lot of things. First, it means the graph is a line. It means when you graph this function, you get a line. Second, because the graph is a line, its formula, we know exactly how it is because it's a line, otherwise it doesn't work. Can you go back to the final part? And okay, I will do it and then I have to move on. Are you with me so far? Minus 72. Yes, and then minus 72 gives me the plus 72. I distribute minus 7x minus plus 70. I need to isolate my y. So I have to take away 72 from both sides. So I will get y equal minus 7x plus 70 minus 72 minus 2. Okay. Now, another extremely important thing about the linear function, because the graph is a line, it means that if I take any 2 points and I try to find basically the average rate of change is always the same, is constant. Means the function changes at a constant rate. Now, another way to say that, which is the way I actually like it, is the following. What does this mean? It means that if you have any function, it means that the output, so another way to state this is the following. It means the output changes by the same amount, or the output change by the same amount for every unit change of input. Means the output changed by the same amount for a unit change in input. What I am talking about. Crucial. That's what it means. Every time the input changed by 1 unit, the output change. Linear, it means it changed by the same amount. So graphically, this means the following. If you have a function and you graph it, you get a line. It means the following. If you start any point and you let your input change by 1, your output is going to change the slope. If you take another one, it's going to change by the same amount. So this change is always the same. This change is always the same. That's really what characterizes that. Versus if a function, the graph is not a line, this is absolutely doesn't happen. Let us take the problem when you have this nicotine going down. If I move y by 1 unit, the output changed that much. If then I move by the same amount, so I'm not changing, look what happened to the change in output. So here the function decreased a lot. So that's 1. That's 1, a little bit less. So this is not linear. It means the function is not changing at the same rate. Here, it's not. The amount of nicotine per hour does not go down by the same amount. It changes. Linear, it means it's exactly the same amount. And that's really what characterizes linearity. It means things change by the same rate. So the change in output is the same for every unit change of input. Okay, and this would really help us sometimes if we have a table of values. It really helps us to figure out whether this table can present a linear function, yes or no. Okay, questions? Can I move on? All right. So we're going to make this small exercise. We're going to do a lot of simple problems together today. And here, for each of the functions below, decide if f is linear. And the key, and if it's linear, find the slope. The key idea, it's linear if the slope basically is constant. That's really what's linear. It means there is no change, it's constant. And now my question is it the case for each one of them? And if it is, I want you to find the slope. So let us do the first problem. I want to find is the change of y over the change in x the same. Okay, so let's see the first one. Let's read the picture. So here I don't have a graph, and I don't want you to graph it for now. I just want to make sure we can do it here. All right, as x goes from 0 to 1, so delta x is 1. What is the change in y? How much y change? Back to you now. So as x changed from 0 to 1, the output changed. Absolutely -3. It's decreasing. Okay, changed by 1. This is again -3. Changed by 1. This is again -3. So here it's simple because I took the same change in x. So my change in x was constant. So here the change in y over the change in x is constant, is equal to -3 all the time, always. That's definitely, if we graph, we're going to have a linear function. So it means if you start putting those points and then sketching them, 5, you go down by 2, and then you, sorry, by 3, then you go down by 3, and you connect them, you have an honest to goodness straight line. Okay, so that's from the table. How about this one here? Again, I'm letting x change by 1. By how much y is changing? By how much? From 1 to 2. So it's increasing by 1. Okay, now I'm letting x change another unit. What happened to y? It increased by 3 units. So delta y over delta x here is 1. Delta y over delta x here is equal to 3. That's definitely not linear. And actually, if you sit down and graph this function, if you sit down and graph it, you will feel that at 0, I am at 1. I move 1 unit, I am at 2. So this is my 2. Okay, so from here to here, that's the change. Now at 2, my function is 5. So this is 2, 3, 4, 5. You can see how much the function jumped. Because there is no way we can fit a line here. No way. The function is actually curving. That's definitely not linear. All right, now we'll do 2 more problems, C and D. C, I give you a minute to give me the answer, and then I give you 2 minutes to give me the D. Is D linear? It means, is the change of y over the change in x the same? If it is so, what is the slope? Okay. All right. What can you say? Is it linear or not linear? Are you guys doing the math? What made me pick linear? Kevin, tell me linear. Anybody agree with him or disagree? Connor, tell me no. So we have different answers. All right, let me check. Okay, what's the change in x from here to here? Means between -2 and 0, x changed by 2 units, right? By how much y changed? Okay, from -3 to -1, it means -1 minus -3. It means this is 2. Okay, now from here to here, x, I'm giving you so far the same change at 2. Between -1 and 1, also the function went up by 2. Between 2 and 4, the change in 2. Between 1 and 3, also 2. 4 to 6, the change in 2. 3 to 5, the change in 2. So why not, Connor? The change of x, the change of y, over the change in x is actually 2 over 2. 2 over 2, 2 over 2, 2 over 2. It's equal to 2 always. So we have really to check if it doesn't work. That's linearity. So it means every time the input changed by 2, so I'm giving you really a constant change, but I dropped it here. Every time x changed by 2, the output changing by 2. So if you sit down and try to graph the function, you will definitely have a straight line. There is no way out because that's really what the picture here. So, but the picture here is the following. Okay, at -3, we are at -2. So this is -2. And then what happened? At -1, we are at minus 3, my apology. Then we are right here. So we move by 2 here. My output went by 2, 2 and 2. 2 units later, my output again went by the same amount, 2, 2. 2 hours later or 2 units later also went out by the same amount. So if we actually connect those, we're gonna have an honest to goodness line. And the slope here is, oh boy, nobody corrected me. And the slope in this case is 1. That's the common slope. Now what about the last one? Is it linear? This is a bit harder. Okay, from here to here, the change, x changed by 2 and y changed by how much? 10 minus 4, which is 6. Here, x changed by 3, y changed by how much? 19 minus 10, which is going to give me a 9. So in this case, I don't have the same change in x, I agree, but the question is the slope, is the rate the same? Okay, from here to here, the change is 4. From here to here, the change is like 31 minus 19. How much is going to give me? 31, you're going to take 10, 21, you take 9. That should going to give me 12. Okay, so now the question is it the rate constant? So let us compute. For x between 1 and 3, so I'm looking now at the ratio. Delta y over delta x, 6 over 2, 8, 3. Now, between 3 and 6, so the change, is it the same? It's 9 over 3, which is 3. So if we graph this, we start connecting. So far, it looks very good. Let me finish it. 31 minus 19, that's what we did actually, over 10 minus 6, that's what I am doing, but we're doing it in our head, is 12 over 4, which is equal to 3. So this seems like a linear function because the average rate is actually not a change. Okay, so graph it, if you have a table, the only way we can figure out that this data fit into a linear function is actually we just see, okay, is it growing by the same amount every unit? Is the average rate the same? Okay, please ask questions as you move. The last problems we are going to do today, again, concern linearity, is that like some simple word problem where we emphasize the meaning of the slope in those problems. So you guys have a bright space. There is a worksheet. Go to the worksheet content, and that is worksheet 6. And we're going to work on it because usually the printing is not very clear. So worksheet 6, go to content, and there is a worksheet. It's a simple one, but the idea is the meaning of the slope is important in word problems. Did you guys get hold of it? So go to content on Brightspace, worksheet number 6, please open it. And I hope to do all those problems with you, okay? Simple, but give us more input into the meaning of linear. What does it mean something is changing linearly? Okay. So in the year 2000, the population of a town was 5,000. So initially, after that, it increased by 50 a year. So the increase is constant. Every year it increased by the same amount. And this increase is expected to continue. And let T represent the years after 2000. So T equal to 0 correspond to 2000. That's really what it means. And after that, we change. Let that be the function that is assigned to T the population of the town T years after 2000. Okay, very simple scenario. And usually the question is this a scenario of a linear function? That's really my idea. Okay, so to do that in this simple scenario, my question is fill in the table below. So, okay, you guys tell me what should I write here? At t equal to 0, what is f of t? So tf is the function. You give it the year, that's my f, and it's spit out, not the year, sorry, the year after, so the number of years after 2000. That's usually my input. And what the output is the population. All right, so t is the number of years after 2000. That's what t represents. So t equal to 0 correspond to 2000. So initially we have 5,000. That's the initial population. About 1 year later, how many do we have? Every year and constantly. It increased by 550. So it's an absolutely, that's a typical linear scenario, the same amount every year. After 2 years, I add another one. So I will have 5,100. So I'm adding every year 50. I'm adding 50, constant. After 3 years, you can imagine I'm adding another 50. It means 5,150. That's linear, the same amount all the time. So now if f is f linear, of course f is linear because the change in output over the change in input is actually a constant. So here, because the change of y over the change in x, here is always 50, which is always the same. So we're changing by the same amount. Another question, if so, identify, so it is linear. Identify the slope and give it meaning, give it unit and explain its meaning. So what's the unit of the slope? What's the unit? Okay, what's the unit of the slope? People per year, crucial. What the slope is telling me, not people, the slope tells me by how much your output, which is the population, change per unit. That's what the slope tells me. It means the unit of the slope is, the unit of the slope, unit of slope is your output, whatever it is. Here it's population. If the unit of output per unit of input, whatever the unit of output is, and whatever the unit of input is. So here, people per year. That's the unit of my slope. Explain its meaning. What does the slope tells me? Tells me that every year, constantly, every year, the population increased by 50. It means every year, and the word every important, that's what linearity is, the same rate. Every year, population increases by 50 at a constant rate. Every year, the population increases by 50. Now find the formula for f of t. Okay, I'll give you 1 minute to give me the formula. It's linear. We know 2 points. And we know the slope, basically. So I don't know. What's the formula? And then we talk about it. Okay, you have, all of you have 2 minutes to give me the formula for that. We need slope and we need a point. Then we can find the formula. Okay, Kaylee is giving me the point. Actually, we have the intercept here. It's 0, 5,000. That's the B. So the B, that's the intercept. It means the B here is 5,000. That's what we're starting with. Okay, and that's really actually the intercept. And the slope is 50. It makes a lot of sense. So what's the formula here? It's 50t plus 5,000. That's really the formula. It make actually, and if you want to sketch the graph. All right, a word about the graph. When we sketch the graph, the input always go on the horizontal and the output goes on the vertical. It means here the time and here the population, all right? So what is the formula? So here the population, so assume that's totally off scale. We start at 50,000, at 5,000, and then we grow every year by 50. So basically every year it grow by 50. Every year grow by 50, it's gonna go like that. And every unit of time, the change is per 50. Okay. Now, in what year will there be 10,000 people only in the town? What am I asking you for? Okay. In what year? So that's the 5,000. In what year they will be 10,000? Basically, all right, how would we do that? Okay, you guys solve it and tell me the answer. I actually don't know what the answer is. I didn't do it. Okay. 100. Anybody agree with, okay, email, I cannot read name. Anybody agree with Connor? All right, so let's see how we're gonna do that. Okay, so it means here, we want the output to be 10,000. So we have to set, so we're gonna like to find the time such that 50t plus 5,000 equal to 10,000. That's really what we want. Which time will give me an output of 10,000? So it's a simple equation that we have to solve. I take away 5,000 both sides. So I will take away 5,000, which gives me 10,000 minus that 5,000. I divide by 50 across. And then get 100 years. And the unit is years, of course, because we're finding the input that gives me an output of 10. So if this function or this population keep growing by 50 years, every year it's going to take it 100 to double, basically, to go to 10,000. All right. That clear? So now I want you to do the second one. First, is this the scenario of a linear function? And then after you decide, you tell me what's going on. So I will give everybody, I'm gonna give you like 4 minutes to interact with the problem and see what you guys come up with. Please read it, ask yourself, is it a linear scenario? It means, unless I gave it to you, I don't know. No, is it a linear scenario, yes or no? And then what's the formula? All right, Kaylee is giving me an answer. Do we agree with Kaylee? I think. Okay. First, is it linear? And what's the key? What give away that it is a linear function? What did give it away that when we graph it, we're gonna get linear? Who can tell me what in this sentence give it away for us? Tell me that it is a linear behavior. No, no, not the 4,000. Not the 4,000. Be more precise. Per year. Exactly. It's per year and expected to continue. That will give away that it's linear. It means it's by the same amount every year. That's the linearity. That's really linearity. Why it was losing? You know, when you buy a car, unless it's an antique car, it actually loses value, right? You know, if you buy a car like me, which is an old Toyota, you know, it's going to lose value, you know, after so many years. That's really why it's losing. So let us see what's the situation here. So if we don't have always to make a table, but I make it just to make sure we understand the problem. So T is time. That's my input. And f of T is value of the car. That's the value of the car after T years. So in 2010, which is T equal to 0, the value of the car was 30,000. And it decreased by 4,000. It means after 1 year, the price went down by 4,000. So it went down by 4,000. Now you don't have to do that. I'm doing this so for us to understand. It went down by 4,000. It means it is at how much? 26,000. So if you want to go sell it, that's its value. And it keeps going along the same line. So after 2 years, for example, you're losing another 4,000, which will leave me as 22,000, and so on and so forth. Okay, that's typical linearity. Now, what's the slope in this problem? The slope is per year, what's really happening. Now, every year here, it's losing. So it's negative because we're losing, minus 4,000. And what's the unit of the slope? Even though I did not ask you about it, but I know that I usually do. What's the unit of those slopes? If I asked you the unit, what would you say? No, not dollars. No. I want to consider this correct. Who would like to dollars per year? That's what it is. It's dollar per year. It's not dollars. It's $4,000 every year. Because if you tell me the slope is 4,000, I have to ask you, not the slope. The interpretation is $4,000, but what $4,000 what? It means per year. So the unit is unit of output, dollars, unit of input is year. So it's losing 4,000 per year. That's my slope. In this particular scenario, not always, I have the intercept. I don't have to have it. In this particular scenario, I have the intercept because this is the value at 0. Out of the problem, I didn't give you the intercept. We have really to find it. So now what's going to be my function is minus 4,000 T plus 30,000. And this totally fit into my scenario. If T is 0, I have 30,000. After 1 year, it's the 30, I took away 4,000. After 2 years, it's 30. Actually, I took away twice 4,000. One the first year, one the second year, leaving me with 22,000. And the unit is output per unit of input. Okay. Can I move on? Yes or no? And so the y-intercept is always, absolutely. The y-intercept is the output when the input is 0, right? The y-intercept, because it's on to always, on the x-axis, on the horizontal axis, they are the input values. On the vertical axis, these are the output values. Always. That's how graph here. So if I want to graph here, if T is 0, my output is 30. That's my intercept, that's an output. And every unit is decreasing. Sorry, I should have put 30,000 above. It's decreasing by 4, So that's really what's happening to the value of my car. So the output is the input. Sorry, the intercept is an output when my input is 0. It's this one right there. And always input on the horizontal, the output on the vertical. That's how we graph a function. Okay, I move on. Very good. Now, please keep asking questions. They are very, very useful, to me at least. Okay, now we're gonna go to number 3. Sorry. And this time, actually, I don't know, you guys read it a little bit and then we talk about it. You guys interact with the problem. So what is my function? It's very similar situation like before. So I have a function, you give it the time, and the function gives you the value of the car. Okay. But here I told you that we assume that the function is linear. So this is, I'm giving it to you. I'm not asking you, is it linear? I did not give you any info to really tell you it's linear. You know, it's not like the previous problem where I told you it decreased by that much per year. That's linearity. Here, I didn't tell you that. I told you we're gonna assume it is linear, okay? And the question is, what's the slope? Give it unit and explain its meaning. So what's the slope? Read the problem. Figure it's minus 1,200. That's what Kaylee is giving me. Do you guys agree with Kaylee? Minus 6,000. Okay, let us read the info. Let's read the info. In the year 2010, so that's the time, and that's f of t. T equal to 0 is the year 2010 for us. In the year 2010, that's my 0, the value of the car was 30,000. Okay, and then what did I say? The value of the car decreased by 6,000 in 5 years. Crucial. It means for t equal to 5, it decreased. So it went down by 6,000. So that's gonna give me 24,000. It went down by that over a 5 years period. Okay, so what's going to be the slope in this case? All right, so this is going down by 6,000, but it's not over 1 year. It's going down by 6,000 over a 5-year period. So yeah, because it's 5 years. So the slope is going to be exactly, so minus 6,000 divided by 5. And that's where the minus 1,200 is coming from. Okay, so I did not tell you per year, that's what's happening. I told you it's linear, but the information is not per year. The information is t equal to 0 and then t equal to 5. Okay, and my question will be always the same. What's the unit? It means dollars per year. It means the value of the car is decreasing, value of the car decreasing by, that's the negative, reflect the decreasing, by $1,200, and that's not enough per year. Without per year, the 1,200 are actually meaningless. They don't tell me anything. Okay, so that's really what the slope here. The previous problem, I told you 5,000 every year. That's why the slope was 5,000. Here, I didn't tell you that. I gave you the value after 5 years. The slope is per year. The slope is the change per year. So minus 6,000 over the 5 years period, I have to divide by 5. All right. Now find the formula and sketch the graph. So that's really my slope. So what's the formula? So now here, again, it's a simple scenario. My slope is minus 1,200. And in this particular problem, I actually gave you the intercept because, so in this problem, B, which is the value of the function at 0, is 30,000. And it means that f of t equal minus 1,200t plus 30,000. And if you really think about it, it really makes a lot of sense because it's changing every year by 1,200. So at t equal to 0, it's 30,000. After 1 year, it means t equal 1, you're taking away 1,200. After 2 years, you take away twice that much, and so on and so forth. Graphing, again, time, value of the car. So here, the value of the car, and here, the input, time in years. And then 30,000. So we're gonna put it right there here. And every year, it's going down by 1,200. Every year is losing that much. So this is the change in output. It's changing that much. That's the picture we have. So in 5 years, it comes 1, 2, 3. In 5 years, basically, it's 5 times 1,200. It's going to go down by 6,000. Okay. All right, now let's look up at the last problem. Again, you guys read it. SARS was a severe acute respiratory system that was, it's like now, the COVID-19, it was not as brutal as this one, but it was also a virus that people had to struggle with. So it's about the time some of you were born, actually. We had the same issue, but it wasn't as strong as what we're going through now. So I'll let you interact with the problem again and figure out every piece of it, and then we'll take it together. Please get going, all of you. Uh, 30t plus 79. Anybody got an answer like Kayla or Kaylee? Sorry. Anybody else? So let us analyze. So again, this is a situation where I told you it is linear because there is no reason why the way the number of cases increasing is linear. Right now, COVID-19, the increase, especially at the beginning, was not linear. Actually, if we graph what's happening with the COVID-19, if we start graphing the number of cases, it was not increasing by the same amount every day. Actually, the graph goes like that. So at the beginning of the virus, if you guys watch the graph, it actually went like this. It was not increasing by the same amount every day. No way. Because every person was giving it away to so many others. It wasn't increasing by the same. It was not a linear growth. This one at the beginning was linear, and that's why I gave it to you. So find a formula for f of t. So here I'm telling you that it's growing by the same amount every year. So let me collect the data to see what we know. So now my input is time and my output is the number of cases. Initially, I have 79. And then after 7 days, I have 289. Okay, and it is linear. So it means basically it's increasing by the same amount every year. So now we need to find a formula. So I need the slope. Okay, what's the slope here? It's the change by how much the number of cases changed between initially and after 7 days, by how much they change. So they change by that much. The value always at the largest value minus the value at 0 here, divided by how long it took to do this change. That's really the slope. So 79, I mean, I think Kayla is right. 79 take away 89, that's going to give me 210. 210 divided by 7. So this is going to give me 30. Okay, that's the slope. So now what's my formula? In this particular scenario, we have the intercept, which is 79. As I said several times by now, I don't have to give you the intercept. So the slope is going to be 30t plus 79. That's the formula. So we have 79 cases. After 1 day, we have 79 plus 30. After 2 days, 79 plus 60, and so on and so forth. Now identify the slope, give it unit, and explain its meaning. So the slope is 30. That's not a big deal. What's the unit of the slope? Unit of the slope. People per day. Can we do better than people? Cases per day. Per day. Case, no, cases I won't accept. 30 cases per day. That's the unit. It's what happened in 1 day. Okay, the slope is what happened in 1 day, because watch how did we get the slope. When I took this difference, what am I looking for? It means I'm telling you. So and we computed this difference, we got 210. What does this 210 tells me? By how many cases, about the jump in cases between t equal to 0 and t equal to 89. Means from here to here, we have an extra 210 cases. But this happened over a 7 days period. So per 7 days. So per day, so when I'm dividing those 210, so that's by how much they increase, but over 7 days, when I'm dividing them by 7, I'm actually getting per day. So that's how you can analyze the slope. The unit here is cases. The unit here is days. That's really make it very easy for us. The unit of the slope is cases per day. Cases per day. So it means that because I told you it's linear, it means the number of cases were increasing at a constant rate. The number of cases were increasing at the constant rate of 30 per day. Every day they increase by that. Okay, so the slope really tells me how the output changes per unit of input. Okay, that's really, and linearity tells me it's the same rate, and the slope give it a meaning for this rate. Okay. All right, so okay, that's it for today. For your homework, please finish Moodle. A lot of you are not doing it. After today's lecture, I mean, you should be able to do all of them, and email me if you're having issue. And I'm going to assign some problems for next time. And those are not the Moodle. Those are practice along the line that we were doing today. So I will have some from the book, probably 2 or 3 some from the book. And I may give you an extra problem, just worksheet along the lines of interpreting the slope, which is I consider essential in this course. Right? Any questions before we let go? Any questions? If anybody have any questions, they can stay. Yeah, you can do that, Zach. Yeah, or you can come to my office hours, like tomorrow, and then I can help you, whichever is more convenient for you. Okay, so you can either email me or come to my office hours, whatever you like. Anybody else? Any other questions? Okay, so I can bye for the rest of you if you don't have any questions. Bye-bye.